Question 5 features a very similar debate to one that is featured in P7 that you need to know about for that, the Curtis-Shapley debate. This one is seen as being between two different astronomers, Curnow and Moore, who are arguing about whether the Andromeda Nebula is inside the Milky Way or outside the Milky Way. Now, the threshold that they've used to decide where the edge of the Milky Way galaxy is 160 light years. So for Curnow to be right, he needs to find evidence that Andromeda is less than 160 light years away. Whereas for Moore, he needs evidence that if he wanted to prove that Andromeda is outside the Milky Way galaxy, he needs to find evidence that Andromeda is is greater than 160 light years away. And part B here then gives us some evidence that Andromeda is actually 1,000,000 light years away. So that obviously supports Moore's theory more than it supports Curnow's. However, it's never possible to say that a theory is completely proved false or completely proved correct. So we can only say that it decreases confidence in Curnow's theory and increases confidence in Moore's theory. And if we look at the final part of the question here, suggests reasons why scientists do not always give up on a theory when new data appears to conflict with it. Well, let's have a look at the mark scheme for that one. So there's lots of available marks here. You just need to identify any two of these things. So it could be that the data that they've found is incorrect or unreliable. In this case, maybe it's the evidence that it's 1,000,000 light years away was not right. It's possible that a slight change to the evidence in the future could make the old theory fit the data. It might be that there's just not enough data. There's not enough evidence, so they need more data to be collected. Anything like that. If you're saying these things, you're going to pick up marks. An important point about older explanations is that they've usually been tested more times, so there's probably more data to support them. So one piece of new data would have to undermine a lot of old data for it to really change the scientific consensus. And finally, here scientists may not like to change from established ideas. They've done a lot of work on the old theory, and they want a lot of evidence in order to discount that one.